The race to build the world's most powerful AI chip just entered a new era. NVIDIA has unleashed a technological powerhouse that's not just winning every benchmark, it's rewriting what's possible in artificial intelligence. From training massive language models to running real-time AI inference, from research laboratories to cloud data centers, this new architecture is setting records that competitors are scrambling to match. This is the story of how one company's latest innovation is fundamentally changing the entire landscape of AI computing and what it means for the future of technology. The beast that changed everything. For years, NVIDIA dominated the AI chip market with a Hopper architecture, but standing still wasn't an option. Competition was rising, costs were climbing, and the demands of modern AI models kept growing exponentially. So NVIDIA did what it does best. It went back to the drawing board and created something revolutionary. The result? Blackwell, an entirely new GPU architecture that doesn't just inch forward, it leaps ahead of everything else on the market. Named after David Harold Blackwell, a legendary mathematician who broke barriers as the first black scholar ever inducted into the National Academy of Sciences, this chip carries the weight of a monumental legacy, and it delivers on that legacy with brutal efficiency. When Blackwell arrived, it immediately dominated every serious performance test thrown at it. In the most rigorous independent benchmarks available, MLPerf testing, Blackwell achieved the best per GPU performance in large language model evaluations, crushing previous records. But that was just the beginning. Blackwell isn't a modest upgrade. It's built on cutting-edge 3-nanometer technology and features something called multi-die GPU modules connected with NVIDIA's newest NVLink technology. Think of it like stacking multiple specialized processors together and connecting them with the fastest possible communication highway. To put it simply, this means the chip is faster, smarter, and more efficient at handling the kinds of calculations that power modern artificial intelligence. The numbers tell the story better than words ever could. Blackwell delivers over 1,000 tokens per second per user, a 15-fold improvement compared to the previous generation. That's not just faster, that's transformative for anyone working with AI. Training massive AI models costs money, billions of dollars in research budgets and computational resources. For organizations running the world's largest language models, that cost matters enormously and directly impacts their ability to compete. Blackwell achieves something almost miraculous. It enables real-time generative AI on trillion-parameter language models at 25 times less cost and energy consumption than its predecessor. When you're managing data centers with thousands of processors running continuously, these efficiency gains translate into hundreds of millions of dollars in savings annually. Every watt matters in a data center when electricity represents one of the largest operational expenses. Every fraction matters when you're running a business that depends on AI responsiveness. Blackwell wins decisively on both counts, making previously impossible projects suddenly feasible. Going beyond Blackwell, the Blackwell Ultra advantage, innovation doesn't pause. In early 2025, NVIDIA unveiled the next evolution, Blackwell Ultra. This isn't just Blackwell with a fresh coat of paint. The enhancements are architectural, meaning they run deeper than the surface level. Enhanced tensor cores, the specialized circuits that perform the mathematical operations behind AI, deliver even more computing power per square millimeter. The upgrade path was deliberate and strategic. Blackwell Ultra doesn't just match what came before. It builds on it with breakthroughs in instruction parallelism, boosting single-core computing power density to double what Hopper could achieve. For the first time, a single unified architecture could seamlessly handle full precision floating point calculations, half-precision formats, and even experimental lower precision formats designed for efficiency. No software rewriting, no compatibility headaches, just flexible, intelligent computing that adapts to what the job demands. The benchmarks proved it worked. When Blackwell Ultra entered competition at MLPerf testing, the industry's most respected independent benchmark, it dominated. It set records across multiple categories. It delivered the fastest training times across all 7 MLPerf training benchmarks. It achieved the fastest inference speeds on reasoning-intensive models. Llama 3.1, a cutting-edge language model with 405 billion parameters, trained on Blackwell in just 27.5 hours, a 2.7 times performance multiplier compared to previous systems. The future arrives, Reuben and the next generation. But NVIDIA wasn't satisfied. While Blackwell was still proving its dominance in laboratories and data centers worldwide, NVIDIA's engineering teams were already working on what comes next. They revealed 6 new chips under a single platform called Reuben, capable of supporting mixture of experts models, systems that use specialized neural networks for different tasks at extraordinary scale. These aren't incremental improvements or marketing exercises. They're another quantum leap forward in what's technically possible with silicon. The Reuben platform introduces innovations in the latest NVLink interconnect technology, enhancements to the transformer engine responsible for the computational heart of AI workloads, and a brand new CPU architecture called the Vera CPU designed from the ground up for AI workloads. The results are staggering. Reuben promises agentic AI and advanced reasoning inference at up to 10 times lower cost per token compared to Blackwell. When training massive mixture of experts models, Reuben accomplishes in 4 GPUs what previously required 12, multiplying productivity while dividing resource requirements. These aren't theoretical numbers developed in isolation. Real organizations with real products are already deploying Blackwell at massive scale. Every major cloud provider on the planet, Amazon Web Services, Google Cloud, Microsoft Azure, and others, are rapidly incorporating these chips into their infrastructure and building new services around their capabilities. Every major server manufacturer is redesigning their systems to leverage the architectural advantages that Blackwell provides. Tesla, Google DeepMind, xAI, and countless other organizations ranging from startups to Fortune 500 companies are integrating these processors into their next-generation AI infrastructure and production deployments. Why this matters beyond the numbers. The impact extends far beyond the data center. When inference costs drop 25 times, applications that were financially impossible become viable. When training time drops dramatically, researchers can experiment faster and iterate more quickly. When energy consumption plummets, the environmental footprint shrinks, while economic viability improves. These aren't just hardware improvements, they're unlocking entirely new possibilities for what artificial intelligence can do. Data centers currently consume roughly 4% of global electricity. The AI revolution is accelerating that consumption. NVIDIA's architectural improvements mean organizations can do more work with less power. That matters for the environment. That matters for operating costs. That matters for the feasibility of deploying AI across industries that previously couldn't afford it. The competitive landscape is shifting continuously. AMD's MI300 accelerator is improving and gaining traction in specific markets. Google's tensor processing units are advancing rapidly for specialized workloads. Startups with fresh ideas and novel approaches are emerging, some focused on specific industries or problem domains. But Blackwell and the roadmap leading to Reuben represent something distinctly different. A holistic ecosystem approach where GPU design, CPU design, interconnect technology, and system architecture all evolve together in perfect synchronization. It's this integrated thinking that compounds advantages and makes the gap harder to close for competitors playing catch-up. The benchmark breakdown. What exactly does breaking every benchmark mean? MLPerf testing is the independent standard that matters most in the industry. These benchmarks test different aspects of performance: training speed, inference speed, reasoning capability, and energy efficiency. Blackwell achieved the best per GPU performance in question and answer benchmarks based on large language models. When competing against everything else on the market, it won. For training, Blackwell delivered the fastest times on multiple challenging benchmarks, including those testing recommender systems, object detection, and graph neural networks. For inference, what happens next remains to be seen. But one thing is certain, the benchmark scores are impressive. The real-world applications are expanding, and the capabilities enabled by these chips are reshaping what's possible in artificial intelligence. The race continues, competition intensifies, and the pace of innovation accelerates. This is just the beginning.